Hi, this is section 7.1, integration by part. Before I begin with a problem, I want to make sure that you remember the formula. There are two formulas. This is the easier one to remember. So integrate u dv equals to u times v minus integration of v du. So the most important part of these problems is you need to figure out which one is u and which one is dv. Let's begin with an example. This is actually a problem from the book. We want to integrate square root of x ln x dx. Okay, so which one should be u and which one should be dv? In this case, you can see that u should be ln x, because when you take the derivative of u, it's going to be really easy. And then dv should be the other part. So dv in this case should be square root of x dx. After that, we need to figure it out. Du. So du is going to be 1 over x dx. And we want to get v as well. So you see right here, this one, if you want to rewrite, it should be x to the 1/2. So when you integrate, you should get 2/3 x to the 3/2. Then by the equation right here, we just plug it in. So we have the original right here is going to turn into uv. So it's going to be 2/3 x to the 3/2 times u which is ln x, minus the integration of v, which is 2/3 x to the 3/2 du. Over x dx. Okay. So you can see right here, we should simplify it. It's going to be 2/3 x 3/2 times ln x minus, and I want to simplify this part right here. So you can see that this is x to the 3/2, and this one right here, you want to rewrite and move it. So it's going to be x to the negative 1/2. So 3/2 plus negative 1/2 is going to turn into 1/2 dx. Okay. So that's going to be easy to integrate. So we have 2/3 x to the 3/2 ln x minus, and then we just have to integrate that. So it's going to be 4/9 x to the 3/2 plus c. And that's our answer. For example 2, I want to try an algebraic and a trig functions. So you can see right here, x is really easy to take the derivative. So that should be u. So I'm going to let u to be x and dv to be sine of 10x dx. So when you differentiate, we're going to get du it's going to be 1 times dx. And then when you integrate dv, you ended up with negative 1 over 10 cosine of 10x. Okay. So don't forget that this one right here, when you integrate, you use substitution. So hopefully you still remember use substitution. Now, we're going to plug it in using the integration by part formula. So we ended up with, this is the original. Now we're going to get u times v. So we have negative 1 over 10 times x. That x right here is that u. Cosine of 10x minus integrate u integrate v du. So I have v du. Okay. I can definitely simplify this. So I'm gonna go ahead and take the negative 1 over 10th out. So it's turned into a positive 1/10. Integration, cosine 10x dx. This one should be really easy to integrate. You just have to use u substitution. So we ended up with negative 1 over 10 x cosine 10x plus 1 over 10. And then I have to take care of that 10 right here. So it's going to be another 1 over 10 sine of 10x plus c. Let's clean it up. So we have negative 1 over 10x cosine of 10x plus 1 over 100 sine 10x plus c. And that's your final answer. Let's try to evaluate an integral this time. So you see right here, I have the lower limit and the upper limit. This time, as you can see, we have w squared and we have ln w. In this case, I'm going to let u to be ln w and v to be dv to be w squared dw. So let u to be ln w and dv to be w squared dw. So du is going to turn into 1 over w dw. And v is going to turn to 1/3 wq. Let's plug it in. So same thing. I'm going to have uv. So I'm going to put v first. One-third wq ln w. And we have to evaluate from 1 to 2. Minus integrate 1 to 2 v du. So it's going to be 1/3 wq 1 over w dw. Okay. So I have v du. You can see right here, we can simplify wq and w. So it's turned into a w squared. dw. Okay. All right, I'm going to integrate. So what I have, so when I integrate, when I evaluate for this part, I will have 2q. So that's turned into 8. And we have ln 2. And then I have 1. But if I put it in here, it's going to get 1/3 right here, but ln 1 is just 0. So everything turned into a 0. For this part, we're going to integrate. We get 2 plus 1 is 3 divided by 3. So this one turned into a 1/9. And then I have W, Q, and I want to evaluate from 1 to 2. So this, the first part turned to a 3rd ln 2. The second part turned into minus 8/9 minus 1/9. So when I simplify it, I'm going to keep the exact number. So 8/3 ln 2 minus 7/9. And that's my final answer. For this problem, you can see that we don't have a product. So we cannot just go straight into integration by part. We're going to have to do some substitution here to turn it into a product. So first, I'm going to let t to be square root of x. Now, if I square t, I'm going to end it up with x. So 2t dt is going to be dx. So I take the derivative of that. So now we're going to rewrite e to the square root of x dx is going to turn into the function of t, which is e to the t, 2t times dt. Now we can use integration by part. And now we're going to let u to be t. So du is going to be dt. And v is going to be e to the t. Because dv is e to the t dt. Okay. I can take this 2 out because it's just a constant. So let's rewrite 2 integrate e to the t. I'm going to put the t in front, dt. This one turned into 2t e to the t. Right? Minus 2 e to the t dt. So you can see that that 2, I have to multiply for both. And then I have u times v. So that's why I have t times v. And then this is v du. Okay, now we are ready to integrate. So I ended up with 2t e to the t power minus 2 e to the t plus c. Now we're going to go back and substitute everything in for this one right here. So t is actually square root of x. E to the square root of x minus 2 e to the square root of x plus c. So that's what I have for t. And that's our final answer.